Welcome to lesson 6.5, where we are actually going to talk about several different things. We're going to start out by introducing the second fundamental theorem of calculus. To introduce this, we're going to go through a little discovery activity. So let's start right here at number 1. This is the integral from 10 to x. Now here's where the second fundamental theorem of calculus comes in. Up to this point, when we've had our definite integral, the limits have always been numbers. But that's not always the case. I could have limits where they're equations even. So looking down here at these ones, these limits are getting into the realm of equations, not numbers. That's where the second fundamental theorem of calculus comes in. It's about how to find these definite integrals when your limit isn't a number. So let's talk about finding this. So first off, if I want to take the integral of this, I could use my first fundamental theorem of calculus, which step 1 is take the antiderivative, and then step 2 is plug in the limits. That's what we learned in 6.4. So step 1, I'm going to take the antiderivative of this. Well, the antiderivative of a derivative is just itself. Oops. Let's do this again. So let me say that again. This is a derivative. If I want to take the antiderivative of a derivative, I end up with the original equation. They undo each other. So I have the original equation with my limits. Step 2, we're going to plug in our limits and subtract them. So this one's my upper limit, this one's my lower limit. So I'm going to plug in my upper limit, which is x, so I just plugged it in, minus plug in my lower limit, which is 10. So I get f of x minus f of 10. And that's my answer for number 1. Now let's look at number 2. Number 2 says I want to take the derivative of this. Now we have done an example of the past where we took the derivative of an integral and we said, hey, they just cancel each other out and we're left with what's inside. But that only worked on an indefinite integral. When I want to take the derivative of a definite integral, that's different. So that's why we're going to explore this a little more. So I want to take the derivative of this. Well, I just found out that this whole piece from number 1 equals f of x minus f of 10. That's what I got from number 1. So I really want to take the derivative of this. So let's take it one step at a time. The derivative of this first one is going to be f prime of x, the derivative of f of x. However, this second one, that's a number. F of 10 is inputting 10 to the equation. That's a number. And the derivative of a number is 0. So what I really get is f prime of x. So this takes us to this first part of the second fundamental theorem of calculus. This is just like part 1. For any constant a, if I take the derivative from a number to x, so like this, from a number to x, then it's going to equal my original function. So you'll see this one is that one. They're the same, which is exactly what we got here. We had this one and our end answer. They're the same. All that happened is our variable changed. So that's the first part of the second fundamental theorem of calculus. In the next video, we're going to do a little more discovery to find the next part of the second fundamental theorem of calculus.